I just want to say before I get into this that I did originally intend for this video to be about 5 minutes long, and then stuff happened. So let's talk about the staircase project.
I have to tell you something.
Now, in the three-body problem universe, progress doesn't just stall, it is deliberately shut down. With the Trisolarans on their way to Earth, humanity finds itself cut off from the very tools it would need to respond. Sophons, which are subatomic surveillance devices, have been deployed to sabotage fundamental research. No new particles, no quantum theories, no breakthroughs. Physics itself has been locked behind an invisible wall. So what do you do when you can't invent your way out of a crisis? You work with what you already know. The Staircase Project is one of the boldest ideas in the trilogy, and it is a desperate attempt to send a cryogenically frozen human brain across space at 1% the speed of light. No warp drives, no sci-fi shortcuts, just a nuclear pulse propulsion system and a giant light sail, built on real-world science. And for a moment, it looks like it might just work. Now, in this video, we're breaking down the science behind the Staircase Project, how it was supposed to function, why it fails, and why it remains one of the most compelling examples of grounded science fiction in the entire series. In the 21st century, the Trisolarans won't arrive for another 400 years, but humanity isn't free to prepare. Sophons, which are engineered by the Trisolarans, have been scattered across Earth. These microscopic devices that are constructed by unfolding a proton in higher dimensions, etching circuitry onto it, and then refolding it into our universe. They interfere with particle physics experiments, and their effect is simple: no more progress. We're frozen at our current level of understanding. No new science, no advanced propulsion, no high energy breakthroughs. So if humanity wants to make contact, or to escape, or resist in any meaningful way, we're stuck doing it with the tools that we already have: classical mechanics, thermodynamics, and mid-20th century engineering. That's the thinking behind the Staircase Project, which is a plan to launch a tiny lightweight probe carrying a human brain and accelerate it to 1% the speed of light. Now that's about 3,000 kilometers per second, and it has to do it using only the physics that we already know and understand. The concept is simple, but the execution seems nearly impossible. So how do you actually push something to that speed? And that's where the past comes in. Nuclear pulse propulsion. The foundation of Staircase isn't fantasy, it's actually a real concept from the 1950s and the 60s called Project Orion. Now back then, scientists like Stanislaw Ulam and Freeman Dyson proposed a radical form of propulsion, launching a spacecraft using nuclear bombs. Now here's how it would work. The proposal was to mount a giant steel pusher plate to the back of a spacecraft. You then drop nuclear bombs behind it, one after another, and each explosion generates an expanding cloud of plasma and radiation. That cloud slams into the plate, pushing the ship forward. Shock absorbers would then buffer the blast, keeping the structure intact. And early calculations suggested that this could, in theory, accelerate massive ships to 10% the speed of light. That is enormous, with no new physics required. So why didn't we build it? Well, there's two reasons. First is fallout risk. Testing near the Earth would be catastrophic for the entirety of humanity. And then secondly, there were the treaty bans. The 1963 Partial Nuclear Test Ban Treaty outlawed nuclear detonations in space. So Orion was shelved, but it wasn't forgotten. And in Death's End, Cixin Liu resurrects the idea, but this time for a radically smaller payload. Instead of a full ship, it's just a brain. Less mass means less thrust required, more speed, fewer bombs. And that's where the next piece of the puzzle comes in: the light sail. Now, to get the tiny probe to 1% the speed of light, Cixin, or it's Jin in the show, proposes combining two known propulsion methods: nuclear pulse propulsion for massive explosive acceleration, that's what happens in the book, and then light sails for steering and stability and fine control. This happens in the TV adaptation. So that light sail isn't just a visual thing, it's critical to the concept. You see, Photons don't have mass, but they do carry momentum. That momentum can be transferred when photons hit a surface. If it's absorbed, it transfers once. If it's reflected, the force doubles. It's described by the equation P equals hv over c, where P is the momentum, h is Planck's constant, and v is the frequency of the photon. C is, of course, the speed of light. Now, this principle is used in the real world in solar sails, which capture sunlight to generate propulsion. But Staircase upgrades the idea. So instead of sunlight, it's using nuclear detonations. Each explosion behind the sail acts like a supercharged pulse of high-energy photons and plasma. The sail reflects that energy, transferring momentum and pushing the probe forward. Now, I know what you're asking. You're wondering, wouldn't the sail be destroyed? No. Sure, detonating nuclear bombs behind a fragile piece of film might sound like that's not going to work. But in space, things work differently. Remember, there's no atmosphere, so there's no shock wave. There's no fireball like on Earth. There's just expanding radiation and debris. And that's why distance is key. The blasts are precisely timed and detonated far enough from the sail to spread out the energy. And if you have a mirrored sail, it will reflect the radiation, reducing the heat absorption, maximizing the thrust. And then remember, the payload is pretty tiny. There's only like a small cryo-frozen brain to protect, so shielding is pretty basic. Let's be real, this process and concept is not safe, but it's not implausible. Now, like I said, in the book, as far as I remember, they only used the nuclear pulses, whereas in the show they added the light sail. So the two propulsion systems complement each other. You've got the nuclear blasts that provide large, discrete bursts of thrust, and then you have the light sail, which stabilizes the craft and aids with course correction and adds a trickle of extra momentum from the background radiation of solar photons. So the Staircase project combines three core elements: controlled nuclear explosions for acceleration, a reflective sail to capture momentum and maintain trajectory, a brain-sized payload small enough to be accelerated with limited thrust and easier to shield from radiation. None of this is magic. It's all just physics. Now, it's messy, it's dangerous, sure, but it's also brilliant physics. But it still fails. So despite the physics, despite the engineering, despite the sheer elegance of the idea, the Staircase project fails. A single support cable on the light sail snaps mid-flight. That tiny mechanical failure shifts the sail's alignment, causing the probe to drift off course. It misses the final sequence of nuclear detonations, that very stage that would have taken it to 1% the speed of light. But it almost worked. This wasn't a miracle device or a sci-fi cheat code. This was humanity using what it had left. Old physics, old ideas, and just enough belief to give something a try.
But we continue to search. Life looks for life.
So you might be wondering at this stage, could we ever build a Staircase? We're not launching cryobrains into deep space yet, and nuclear pulse propulsion is still illegal under current treaties. But the physics holds up. Everything in the Staircase project, momentum transfer, photon pressure, radiation-driven sails, even staged nuclear detonations, is grounded in real science. Not easy science, not safe science, but real possible science. Now, the closest modern parallel is called Breakthrough Starshot. This is a real-world initiative funded by Yuri Milner, and it's supported by the late Stephen Hawking, and it aims to send tiny probes, just like a few grams each, to Alpha Centauri, not using rockets and not using fuel, but with powerful ground-based lasers pushing ultralight sails to 20% the speed of light. So much faster than the Staircase project, but the same basic principle. Light sail propulsion, minuscule payloads, no onboard fuel, interstellar target. Now, of course, look, it sounds exciting, but the challenges are massive. You need lasers that are strong enough to sustain acceleration across light years. And if you know anything about the US's Star Wars program, you know how hard it is to make lasers that will actually be high power going up through the atmosphere and out into space. You also need fine-tuned aiming over interstellar distances, and lasers they can drift, they will disperse, there's so many things that will happen. You also have to survive impacts with space dust that is happening at relativistic speeds, which can be very damaging. And then there's communicating across 4 light years of silence. But it's not a fantasy. Prototypes are in development, research is active, the dream is real. What about the other half of the staircase, the nuclear part? Well, that's where things get harder. Like, Project Orion was scrapped by the 1963 Partial Nuclear Test Ban Treaty, and the political fallout of detonating bombs in space is still very real. So we're not building staircase, not yet anyway, but we are laying the groundwork for something. Because in the end, Liu's vision is more than speculative fiction. It is a reflection of where we are and of where we could go, and of the lengths that we're willing to travel just for the chance to send a message into the void.
Anything might be out there. The unknown troubles us.
Now, in the book and in the TV show, the Staircase project stands out not because it's fantastical, but because it feels like something we could almost build. It doesn't rely on imagined technologies or speculative physics. It's about working within limits, using what we already know and stretching it as far as it will go. A light sail, nuclear pulse propulsion, a frozen brain. It's an idea rooted in real science pushed to its edge. And while it fails in the story, it's not the science that lets it down, it's the execution. Because it's not a story about unlocking the secrets of the universe. It's a story about doing the best you can when the path forward is blocked. It's an idea that reflects something very real, that science fiction doesn't need to predict the future, it just needs to ask what's possible when the usual paths are closed. Now, for those of you who have read Cixin Liu's books and know what else happens, this is probably the most grounded piece of science in the entire story, and maybe that's why I enjoy it so much. I also really like the fact that Cixin Liu is trained as an engineer, and the execution of this part of the story is more about the engineering side of it rather than the physics, because the physics is established. They just needed to actually engineer it to make it work. So for now, Tianming, or Will, is lost in space, and we'll have to wait and see what happens with that. Anyway, like I said, this was supposed to be a very short video, but then, I don't know, just kind of ran away with it, so there we are. I hope you enjoyed it, and if you did enjoy it, please do consider subscribing if you like more sci-fi science stuff. And yeah, let me know what you think. What do you think about this part of the story, this part of the science? Try to maybe not give spoilers in the comments for people who are following on the TV show only, if you're book readers. But it is something that I think is fascinating in the trilogy altogether. Now, those of us who know where it goes and how bonkers things get. But in terms of thinking about what would we do if science was blocked? You know, like if there was no possibility that we could make any more future advancements, how could we utilize what we already know? Would we make other discoveries if we had to go back and reevaluate things? I don't know. I just think it's an interesting idea and an interesting discussion. I haven't formulated what type of a discussion that would be yet, but maybe it'll be something I'll chat about in the future if it niggles at my brain a little bit more. So yeah, thank you. Like I said, sorry, thanks for watching. Again, I still don't have proper outros for my videos, but you know, I'm Irish. It's how we say goodbye. You just keep saying it over and over again. So, okay, I will leave now. Goodbye. Thank you. Stop saying thank you. Jesus. Stay nerdy.
But we continue to search